Good afternoon, everyone. Take a moment to look at the front screen here and notice that your homework is going to be algebraic and segment proofs, and you have a test next week, November 3rd or 4th, whatever day is right for you. All right, so you should have your notes right now, the properties of equality and segment proofs notes. If you don't have those right now, pause this video and get them so that you can take notes while you're watching. All right, so you should have your notes by now. The properties of equality are going to be a review from last year. So we'll go through those quickly. The addition property of equality states that if you have A equals B, then A plus C equals B plus C, meaning you can add the same number to both sides and your equation will still be equal. Similarly, the subtraction property of equality states if you have A equals B, then A minus C equals B minus C. So if you take away the same thing from both sides, again, your equation will still be equal. The multiplication property of equality states that if A equals B, then A times C equals B times C. Same justification. If you multiply A and B by the same number, your equation will still be equal. And the division property of equality shows the same thing. If A equals B, then A divided by C equals B divided by C. Again, because the equation will stay the same, you're doing the same thing to both sides. The distributive property, if A times B plus C, then A times B plus C equals A times C plus B times C, based off the distributive property. The substitution property states if you have A equal to B, then A may be replaced by B in any expression or equation, right? So if A equals 3, then you could replace A for 3 in any given expression or equation. The reflexive property for any number A equals A. So that means that a value always equals itself. The symmetric property states if A equals B, then B equals A. So if X equals 5, then 5 equals X, right? So you can write it either way. And then lastly, the transitive property states if you have A equals B and B equals C, then A has to equal C because of that commonality of B, which we talked about before. So that was a review on the properties. Right now on the bottom of your paper, I want you to identify the properties for 1, 2, and 3. So pause this video until you are done. Maybe take 30 seconds to a minute here, and then restart the video to continue with the notes. All right, you should be done with these 3 problems. The first problem here is going to be the addition property of equality. You're adding x, y to both sides. Number 2 is the symmetric property, AB equals DE, therefore DE has to equal AB. And the third one is the subtraction property of equality. You have AB plus CD and EF plus CD. The CD goes away, therefore you're subtracting CD from both sides and just left with AB equals EF. All right, so we are going to practice. I want you to get out a piece of paper, and I want you to go through the given statement or the given equation and write down your statements. Now the statements is going to be you solving step by step. Make sure you go step by step, and then the reason is going to be your properties. So take a couple minutes to do that right now. Pause the video, and when you are done, start the video again. All right, you should have all completed this and hopefully checked with your partner. We're going to look at the possible statements here. So because you only have n on your right-hand side, you'll most likely take the 5n over the other side, what you need to know is that we always start off with the given statement. So 5n minus 42 equals 12n. That's reason is because it is our given statement. All right, the next step, as I said, is that we'd probably take that 5n over, so you'd have negative 42 is equal to 7n. And that is our subtraction property of equality. I'm going to abbreviate here. All right, and then people have done this one of two ways. Some people will divide the 7 right here and say negative 6 equals 7n, and that's going to be the division property of equality. Now, in order to, oops, not 7n, sorry, equals n. Now, in order to have your variable on the left side, you could say n is equal to negative 6, and that would be your symmetric property. Now, some people do this part in one step, but you need to make sure that it is separate steps because you are doing two different properties. You're dividing and then you're actually using the symmetric property. So make sure that is in two steps. Other people may have switched around the 7n minus equals negative 42 first, and that is fine. You would have the symmetric property here. And then you would have said n is equal to negative 6, and that would have been your division property of equality. So either are okay. Now that you have that one under your belt, let's try this second one. Again, pause this video, take a couple minutes to write your statements and reasons, and then restart the video when you're ready to look at the next part. Okay, you should have solved this statement here. And we are going to go, or this equation here, we're going to go through it right now. So again, you would have the negative 8w plus 1 is equal to negative 5w plus 10. And that's your given statement. Okay, and then you would have the distributive property. Because you have it on both sides, you may put this in one step. So you have negative 8w minus 1, or minus 8, sorry, is equal to negative 5w minus 50. And that's from the distributive property. All right. And then you would have the subtraction property of, or the addition property of equality. Now, it does not matter which variable you bring, if you bring the 5w to the left or the 8w to the right. However you do it, you would have your reasons accordingly. So this would be, if I brought the negative 5w to the other side, we'd have negative 3w equals negative 42. And this is the addition property of equality. And then we would say w is equal to 14 because of the division property of equality. Now, if you brought the 5w over, you might just have one, or 8w over, you might just have one more step. You would have 42 is equal to 3w, again from the addition property of equality. Then you could either have done the symmetric property here and said 3w equals 42 and then solved it, or you could have said 14 equals w from the division property of equality, and then w equals 14 from the symmetric property. So any of those are fine as long as you are justifying those steps and you only have one step per line. All right, so that sums up our properties. We'll have a little bit of practice there. But the next part that we want to look at is going to be the segment proofs, and this is what's going to be new here. All right, so get your notes and flip over your paper. We're going to look at the segment proofs. So the reflexive property of congruence states that for any segment AB, segment AB is congruent to AB. So just like the reflexive property, but this is just of congruence. All right, the symmetric property of congruence, similar to the symmetric property, states that if a segment AB is congruent to segment CD, then segment CD is congruent to segment AB. And likewise for the transitive property, if segment AB is congruent to segment CD and CD to EF, then AB has to be congruent to EF. So again, those are just like the other properties, but now they are of congruence. Now your definition of congruence states that segments are congruent if and only if they have the same measure. So if AB is congruent to CD, then AB has to equal CD in measure. Likewise, if AB equals CD in measure, then line segment AB has to be congruent to line segment CD. The definition of a midpoint: the midpoint of two segments divides the segment into two equal or congruent parts. So if M is the midpoint of AB, then AM equals MB, where M is your midpoint. And because it's a midpoint and divides it into two equal segments, they have to be equal. And the last definition that we have right now is the segment addition postulate, which states that if A, B, and C are collinear points and B is between A and C, then AB plus BC has to equal AC, right? So if you have AB and BC, that has to equal all of AC. Right, so I want you to pause the video and take a minute to answer questions 1, 2, and 3. We'll do a practice together, and then you'll have time on your own to work on it. All right, so you should have paused the video and answered these 3 questions. The first one, if PQ equals PQ, then PQ is congruent to PQ. That's the definition of congruence. The second one is the segment addition postulate, and the third one is the definition of a midpoint. All right, so again, I want you to get out or use your scrap piece of paper. Here we have our image XYZ, our on a collinear line here, and we're given that y is the midpoint of xz, and we want to prove that xy is equal to 1/2 xz. So we have our statements here, and I want you to give me the reasons for each of those statements based off of what we just learned. All right, so pause this video and take a minute or 2 to do that, and then restart the video. All right, so our reasons here, y is the midpoint of xz is given. Xy is equal to yz is the definition of midpoint. 2xy plus x or equals xy plus yz is the addition property of equality, right? So this 2xy can really be written as xy plus xy, which gives us that 2xy. And the reason we need that 2xy is because we're going to have to prove that it's a half. So because xy and yz are equal, we know that xy this could also be the same as another xy. So you could have xy plus another xy, which would be the same distance as the yz plus xy. All right, and so then again, we just simplify that to 2xy because we're going to have to prove that half. All right, so then we have the xy plus yz equals xz is the segment addition uh, postulate. That should be postulate, not property. Sorry. Um, and the reason that we need this here is because, again, we're going to have to prove that it's half of xz. So we need that xz in our equation. So we're all trying to get down to this equation that we're proving. So we need to prove that xy plus yz equals that xz. All right. Now we have the 2xy plus xz substitution. Some also could have said transitive, and that would have been fine. We could substitute because 2xy plus equals xy plus yz. We can substitute that in, or you could have said 2xy equals xy plus yz, and xy plus yz equals xz. Therefore, 2xy has to equal xz. Again, so either one, substitution or transitive, would be okay. And then lastly, we have the division property of equality because you divided by 2 to prove that xy is equal to 1/2 xz. All right, so that sums up the notes. What I want you to do before you start your classwork is turn to your neighbor and talk about proving the segment proofs or the properties, and then you can start on the classwork and go from there. All right, bye.